Good day, grade 12 learners. Welcome to today's mathematics lesson. My name is Annelin Sindane. The lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. I hope you wrote paper 1 well. Please forget about paper 1. Our concentration now is paper 2. Do not even entertain questions about paper 1. Our focus is paper 2. Now, for revision today, we will go through all the topics that are examined in paper 2, but we will put more focus on trigonometry, as trigonometry has the biggest chunk of marks in paper 2, and we need to collect those marks. But we will discuss statistics, analytical geometry, as well as Euclidean geometry. Now, we will my slides are not moving. Just a moment.
Your pen is not 800%.
800. Let me see. Izobona beforehand. And you keep the camera.
We zoom.
Oh,
Press it.
they will zoom.
Zoom. Okay. So we cut it right. So another 20 seconds. Emergency has a technical error and then
Yeah.
10 seconds. All right, welcome back. Sorry about that. It's a technical issue. It's sorted. It's resolved. So we are aware that for our paper 2 topics, statistics is 20 plus minus 3 marks. Analytical geometry, we know it's 40 marks. Trigonometry is 50 marks. And Euclidean geometry is 40 marks. Now, on our question paper, statistics, it's normally question 1 and 2. Analytical geometry, it's normally question 3 and 4. Trigonometry, it's normally question 5, 6, and 7. And then Euclidean geometry, it's normally question 8. It can go up to 10 or up to question 11, depending on the year. But we should be able to answer these questions. You are able to see the weightings there. For a minimum targeted mark per topic, you are able to see how much you need to get in order for you to get a minimum pass. You must get at least 57 marks, which will give you 45%. But you need 45 for you to get 30%. And then for you to have a bachelor pass, minimum you must get 75, or you get 100 marks for you to get a bachelor pass there. But our target is 100%. It's possible for you to get 100% in paper 2. My advice will be, please, the 10 minutes reading time should be used effectively to plan your work. In paper 2, we have a structured answer book. It doesn't matter which question that you start with. Make sure that you start with the question that you know best so that you maximize, and that gives you confidence. If Euclidean geometry on the question paper is too easy for you, start with Euclidean geometry, answer everything that you know well whilst you have time, and then you go back and finish up those parts that are giving you a hard time. Now, we will move on. Now, the first topic that we look at is statistics. And statistics, it's normally calculator work. We should be able to calculate our measures of central tendency, our mean, mode, median, and we should also be able to determine the range. That is our measures of dispersion. We should be able to calculate our percentiles, quartiles, as well as the interquartile range and the semi-interquartile range. The 5-number summary, we know how to get that one. We should be able to plot and interpret our box and whisker plots. We should be able to calculate measures of central tendency for our grouped data as well. Now, for grouped data, we calculate estimated mean as well as estimated standard deviation, and we should also be able to identify the interval where our median lies. Now, we should be able to calculate variance and standard deviation. We should know the relationship between variance and standard deviation. We know that standard deviation is the square root of the variance, and we know that if we square standard deviation, we get variance. We must know that relationship, and we should be able to plot and interpret our ogives, which is our cumulative frequency graphs. We should be able to identify outliers, and we know the formula for identifying outliers. It is given by Q1 minus 3 over 2 interquartile range, and we know that the upper limit is given by Q3 plus 3 over 2 interquartile range. That's how we get our interval. With anything that is below the minimum of this interval or above the maximum for this interval, it's an outlier. But sometimes, especially in scatter plots, it is easy for us to identify the outlier as it is the point that is the furthest from the line of best fit. Now, we should be able to use measures of central tendency as well as dispersion, and we use that to analyze as well as to come up with valid conclusions or associations there. Now, for scatter plots, we know that our line or the equation, the regression equation, is given by y is equal to a plus bx, and we should be able to calculate the values of a, b, and our r, which is our correlation coefficient, and we should be able to plot our scatter plots. We use our mean for x and our mean for the y values. Our graph always has to pass, our line of best fit has to pass through the mean for x and a point with mean for x and mean for y, and we also get our y-intercept or x-intercept. We join those points, we get our line of best fit. Now, the correlation coefficient, we use it to comment on the relationship between the two given variables, and we use statistical summaries for interpolation as well as extrapolation, where we are supposed, if you are given that our x is this, then we have to get our y, or we are given our y, we have to get the x value for which will be with the other value that we are missing. You can see that I have even put that in bold. Calculator usage is very important for statistics. I know we have been taught the manual way of doing things, but in the interest of time in the exam, kindly use your calculator and always practice with the calculator that you are going to use in an exam situation. Do not borrow a calculator in the morning that you have never used. It will give you challenges. Now, I will move on and look at our statistical formulae. That's how we calculate our mean. The other term for mean, it's average. We must know those terms. That's how we calculate our variance. And we said the square root of the variance gives us the standard deviation. And we know that our regression line is given by that equation. Normally, we are supposed to find the values of A and B, then we substitute them into the equation. Please, it's important that if a question is asking you about the equation, write the values of A and B first, and then you substitute them into the equation. Now, just as a quick one, so that we relax a bit, we are going to look at that question where we are looking at more concepts on our statistics. We are given that Maggie works part-time as a waiter at a local restaurant. The amount of money in rents that she made in tips over 15-day periods is given below. You are able to see that day 1, 35 rand, day 2, 70 rand, and so on and so on. But that data has been arranged in ascending order, which helps us to always check. If you are given data, you must check and see if your data is arranged in ascending order, so that when you are supposed to find our 5-number summary, you use the correct information. Do not just take information without rearranging it, because that's a must that we arrange the data before we can use it for our box and whisker plots where we need to get the 5-number summary. But for this one, it's an easy one. It says calculate the mean for the data. For us to calculate the mean, we know that we will use a Casio calculator. This is a reminder. Please switch on your calculator. Select statistics. This is a one variable statistic. And then you enter your data followed by an equal sign. You enter all the 15 data items. You press AC to save your data. And then you go Shift 1 so that you go to statistics. You choose option number 4. That is where you will get your mean. It's number 2 on your calculator. Press equal sign. You will get your mean. Now, if you followed that, you are able to deduce that your mean will be given by 1420 over 15 using your calculator. But even if you do not show that step, you just write your answer as 94 rand,67, you will get your 2 marks. Then the standard deviation, Shift 1, 4, which is your VAR. Then you choose option number 3, press equal sign. I'm using the ZA plus. So if you're having a newer version, you know where to get this. So you will find out that your standard deviation is 22 rand,69. It's money. We normally round it to 2 decimal places. So instances always determine whether we round up or we round down. But if, for example, this was the number of people, definitely you wouldn't leave your answer as 69 or 67, because the scenario will determine the way of rounding off, because we are dealing with quantities that cannot be decimals in a given case, but money can be a decimal, hence our answer is like that. We move on now. What I want to highlight is the situation in 1.22 where we normally lose marks unnecessarily. The question says, Mary also worked part-time as a waitress at the same restaurant. Over the 15-day period, Mary collected the same mean amount in tips as Reggie. But her standard deviation was 14 Rand. Mary collected the same mean amount, so we underline that, same mean amount in tips as Reggie, but her standard deviation was 14 Rand. Remember, we have calculated. So for you to answer this question, you have Mary, you also have Reggie on the other side. You are saying, you are looking at these quantities. For your mean, we got 94 Rand 67. Reggie, it's also 94 Rand 67. It comes from the same mean. The mean that you calculated in 1.21a, you are going to use it because of the statement that says it is the same mean amount. Then we look at the standard deviation. You are able to see that for Mary, the standard deviation is 14 Rand. And for Reggie, the standard deviation is 22.69 Rands. Let us look at the first question there. Using the available information, comment on the total amount in tips that they each collected over the 15-day period. How do you answer this one? So you are already being guided. That statement which said the same mean, it means Mary had the same mean, Reggie had the same mean. They both worked over the same 15-day period. So meaning their total amount that they collected in tips is the same. It is 1,420. They both collected 1,420 Rands. The amount they collected over 15 days is exactly the same. B, you are supposed to comment on the variation that each of them received in daily tips over this period. We are not commenting about variance. We are looking at the variation. If you look at Reggie's tips, they range from 35 Rand to 125 Rands. For Mary, we are not given information about the tips for each of the given 15 days, but we are given information about standard deviation. I hope you remember this X bar minus X bar plus. We know this interval where we want to find out the number of days where the tips collected will fall within one standard deviation, within two standard deviation. It helps us in scenarios like this. So for us to analyze this, you are able to see that the variance for Mary is 14 Rand. The variance for Reggie is 22.69 Rands. So it means Reggie had more varying tips, and you can see from the table there that the tips for Reggie seem to be spreading a lot. If you look at the range from 35 to 125 Rands, so you are able to see that the range there, it's about 90 Rands. That's how the tips are spreading. I'm not saying you are able to see that there are so many variations. Today they get this, on another day they get even higher values. But if you check for Mary, it means whatever they get as tips, they are clustered around almost the same amount. It's not as varying as what Reggie is getting. So to get our final solution there, you are able to see that Mary's standard deviation is smaller than Reggie's, which suggests that there were greater variation in amounts for tips for Reggie that collected each day compared to the number of tips that Mary collected each day. I have explained this. Most of us, when we come to such questions, we lose marks there because we do not want to explain what the situation is giving. We want to only concentrate on the numbers that we have calculated instead of analyzing and coming up with a valid and acceptable reason around the differences in the amounts that we are getting. We'll move on to the next example. Again, this work we did in grade 11 and most of us have forgotten it. An ogive cumulative frequency graph. We know that this question can come in this form where you are given where an ogive is drawn for the candidates. We are supposed to interpret it, or we are given data in the form of a table and an annexure for drawing the cumulative frequency graph. We should be able to do both and get good marks on it. Now, you are able to see that our ogive is already drawn for us. We need to know that 60 minutes is equivalent to 1 hour because there is no hour there. It's the number of minutes. So some of these basic conversions, we must know them. And we must read and understand the scenario. Sometimes you'll find out that the number of this per thousand. So it means if it is given as 10, it would mean it's 10,000. So we should be able to read the scenario and get what we are given. It says, write down the number of food items ordered from the menu during the first hour. Our time, it's on the x-axis. The number of food items ordered, it's on the y-axis. So our time, it's an independent variable, and the number of food items ordered, it's our dependent variable. These are some of the things that we should be able to see. If you are not sure which one is your x, which one is your y, the graph helps you to see. If you need maybe to enter the information back into the calculator for calculations, you should be able to see which one is your dependent variable, which one is your independent variable. Remember to enter into the correct column your x and y again. So in the first hour, you are able to see that the last point plotted there will have coordinates 60 and 140. Remember, 60 is the time and 40 is the number of food items ordered. And if you check, you are able to get all those points, read from the graph and write the coordinates to help you see what is happening. Now it says the number of food items ordered from the menu during the first hour. Our first hour is 60 minutes. So you take the y value when your time is 60 minutes, and that will give us 140. That becomes the answer. We want to look at the modal class. The modal class gives us the highest frequency. So you are able to see that the change in our numbers, when you look at your y values and you move along the x-axis, if you look at the first point is 0, 0, the second point is 10 and 12. So here it will be 10 and 12. There it will be 20 and 30. The next point, it will be 30 and 78. The next point will be 40 and If you check there 2, 4, it will be 114. The next point will be 50, and if you check the y value there will be 134. Now we want to look at where our y value has the biggest jump. So you'll subtract 140 minus that, it gives us 6. 134 minus 114, it gives us 20. 114 minus 78, it will give us 36. If you have 78 minus 30, that will give us 48. So you are able to see that the biggest jump is between this point and that point, which means the modal class you are taking the time. So you can give this in interval notation. You can say your x is an element from, it's between 20 and 30. Or you would say it will be given by 20 less than x less or equal to 30. In this case, because we're not given a table, we don't know how the inequalities were like on our table. So you will be marked for any of the intervals that you have given correctly, as long as you have got your minimum as 20, your maximum as 30. Then it says, how long did it take to order the first 30 food items? First 30 food items, you are looking at the number of food items. You place your ruler on 30, draw a dotted line. Where you have 30 intersecting with that, you take the value in terms of number of minutes down there, in which case it will be 20 minutes. We move on. How many food items were ordered in the last 15 minutes? These are the questions where we normally lose marks. The last 15 minutes. 60 minus 15, that should give us 45. So it means you come on your x-axis, you look for 45. 1, 2, 3, 4, 5. You place your ruler there, you draw your dotted line up to the graph. Then you take a reading on the other side. You will be able to get the time, the number of food items that were ordered there. But remember, it is the last 15 minutes. So whatever you get as your value here, you subtract it from 140, and that will give you your answer for the last 15 minutes. We move on to the next one. The 75th percentile for the data. 75th percentile, we are having our cumulative frequency as 140. So 75th percentile, how do we get percentiles? Percentile means percent. So you want to find 75 over 100 of 140. You get the frequency, and once you get the number, you go to your graph, get the number, then you take down the number of minutes as your 75th percentile. The interquartile range, we need to use our OGAIV to get our Q1 and our Q3. You must show where you are taking your readings on the graph. That's where the marks are. And then you subtract. We know that our interquartile range is given by Q3 minus Q1. Now I'll move along. You will realize that the solutions are as follows. I have given you the solutions. So the first 1.1, we got 140 food items. We got the interval. The number, we said 140 minus 126. You can see that there we accept a range of values. It's not only one answer which is correct, but you must show where you take your reading. The 75th percentile, you will find out that it will be 105 food items, then you go to 105 and then you go down, you take your reading on the time axis. Then the lower quartile, we said is 35 items. It will be 1/4 times the cumulative frequency, which is 140. Then we get our time there. Let's move on now to the next topic. Analytical geometry. But analytical geometry, we revised it on our last lesson. But I will just mention things that we need to know. We need to solve problems using the distance formula. We should calculate the gradient of a line segment. Remember, this is applying in shapes that are normally given in our diagrams. We need to derive and apply the equation of a line through the given points. Remember, gradient of parallel lines is the same, and once you are given one gradient of one line, you are able to find the equation of the line which is parallel to it passing through a particular point. Remember that. We should be able to calculate our angle of inclination using tan theta is equal to m. Remember, the angle of inclination is what a line makes with the positive x-axis, and our angle of inclination can either be acute or obtuse. You are able to see that one there. The diagram helps you to see. The variables may change, theta, alpha. It can be given in any variable, but we should know the basic way of calculating our gradient. Remember, if our gradient is negative, it means our angle is obtuse. Please do not get negative angles when calculating angle of inclination. We will be losing marks there. We also should be able to find angles using the diagram that you are given. The concept, the exterior angle of a triangle is equal to the sum of the two interior opposite angles. Check your diagram and use the diagram effectively. We have also the equation of a circle, radius r, center AB, and remember also we can be given the equation of a circle, x squared plus y squared is equal to r squared. We know that one, our radius is r and the center is at the origin. Now, we should also be able to use to determine the equation of a tangent to a circle. We should also be able to solve problems that involve properties of triangles as well as our quadrilaterals. We know the basic quadrilaterals, how to distinguish them in terms of their interior angles, as well as their sides, as well as knowing the properties of the diagonals, as this will make our life easy to check whether a shape is a parallelogram or a rectangle. You look at the diagonals. You also look at our interior angles. In a rectangle, it's right angles, whereas in a parallelogram, opposite angles are equal, but they are not right angles. We will also solve problems involving circles that are intersecting. We know that there are scenarios where our circles can intersect at two different points. We look at the radius and the distance should be less than the sum of the given radii for the diagrams. And then we also have circles that are intersecting externally. We will have the distance between the two centers using the distance formula should be equal to the radius of circle 1 plus the radius of circle 2, which is R1 and R2. Where they are not intersecting, you will find out that the distance between the centers is greater than the distance of R1 and R2 added together. We should look at this. Also, dealing with circles, we should be able to see whether a straight line is a tangent or it intersects the circle at two different points. If it intersects a circle once, it means it's a tangent. If it intersects at two different points, it means it is a secant. And then also we should be able to see whether the line intersects the circle or does not intersect the circle there. On our circle equation, we should be able to work with the forms of the circle equation. It can be given as x squared plus y squared plus bx plus cx plus d equals 0. Remember that we use the method of completing the square to find our coordinates of the center and also to get our radius. But if it's given in this form, we are able to deduce the coordinates of the center using the value, because this it's already having the method of completing the square done for us. Now we will move along and look at our information sheet. We know the formulas that we are supposed to use in analytical geometry. Please refer to the formula page. Do not write wrong formulas because it's a common mistake. People write the distance formula with a plus and write the midpoint formula with a minus between the 2 points. Please, let's use our formulas. It will help us. Yes, we are saying you must know them by heart, but it also helps for you to just make sure that you are writing the correct formula and substituting correctly on your work so that we do not lose marks. I will jump to Euclidean geometry. Euclidean geometry, we have theorems that were done in grade 11 and other lower grades. Please know all theorems. Remember the 3, 4, 2 diagram. Check your theorems, group your theorems. Before you answer any question, identify which theorems are there. The centers and chords. Those that are associated with cyclic quads and those that are associated with tangents, as well as our centers. So we'll move on now to Euclidean geometry. You must know the corollaries as well. Visualizing is important in Euclidean geometry. Like I said, geometry learned at lower grades, the geometry of parallel lines, intersecting lines, perpendicular lines, we must know those. Geometry of triangles, quadrilaterals, the midpoint theorem as a special case of proportionality, the converse of proportionality theorem and similarity. We should also know the application of Pythagoras theorems in circle geometry. Now, if we have parallel lines, we know that we have alternate angles, corresponding angles, and co-interior angles. When we are giving reasons, it is important that if you are having x or a1 is equal to 20 degrees, then you are saying these are alternate angles equal. We must name our parallel lines. AB parallel to BC, to CD, sorry. AB parallel to CD. So we should be able to get most of us leave that part of mentioning our parallel lines. We will lose marks. For our co-interior angles, corresponding angles, we must always mention our parallel lines. Cyclic quad, we know that opposite angles are supplementary. Exterior angle is equal to the opposite interior angle. We should be able to use and write the correct reason. Please, for every statement, there must be a correct reason. We have our tangent Tangents, we know that a tangent is perpendicular to the radius, or tangents drawn from a common point are equal in distance. And we know that if two sides of a triangle are equal, then the interior opposite angles are also equal in size. We also have our similar triangles, and we know that similar triangles are coangular, meaning the order in which we name our sides and angles should be the same in the given two triangles. The sides must be in proportion and the angles should be equal. Now, we have our proportionality theorem. A line drawn parallel to one side of a triangle divides the other two sides equally or in proportion. If it is the midpoint theorem, we take it a step further, that a line drawn parallel to the third side from the midpoint of one side of a triangle to the midpoint of the other side, parallel to the third side, will be parallel to the third side, and its length will be half the length of the third side. That's how the midpoint theorem works. Now, we know that a line passing through the midpoint bisects, and we should know the notation of representing our bisection, our right angles. We must know that. So for our examinable theorems, I will just illustrate the diagrams that are given. So these are the theorems that are examinable for our exam. There are 7. There were initially 6. You can see number 2 is the new one that was added in our 2021 examination guidelines. Note that a construction or a construction statement is required when proving the examinable theorems, and we use dotted lines. You will realize that if you know the proof and there's no construction, it's 0 marks. Please make sure you show your construction on the diagram, or you write down the construction statement. Now, you are able to see the diagram that normally comes in an exam, and we know that the construction that we need to make are those ones in dotted lines. Already, once you do that, you have 1 mark before you start answering. If you are supposed to prove the line drawn from center of a circle perpendicular to a chord bisects the chord, we need to prove that AP is equal to PB. Then we also have the theorem, a line drawn from the center of a circle that bisects a chord is perpendicular to the chord. Again, the construction here is the same, but we need to prove that this angle is 90 degrees there. We move on to the next theorem. Now, the angle subtended by the arc at the center of a circle is double the size of the angle subtended by the same arc at the center. You are able to see, and these are the versions of the diagram that may come, but normally from experience, this is the one that is normally coming in our exam. These other two are not popular, but you must also look at them. I will move on to the 4th theorem. Opposite angles of a cyclic quad are supplementary. You are able to see that theorem. Normally, you are supposed to prove that B plus D is equal to 180. The construction that you make there, don't make a construction from B or D. It must be the other sides. And don't make it a straight line, because it will give us problems there. Do your construction and use the steps that are required there. Number 5, this one, I know most of us do not even know the wording of this theorem. We only know the reason, tan chord. We must know the wording in our theorems for us to use them effectively. you are able to see that you are supposed to prove that our angle CBD is equal to our angle BED, or the diagram can ask you to show that ABE is equal to our angle BDE. You are supposed to prove those. It can work in either way. For grade 12, we did a line drawn parallel to one side of a triangle divides the other two sides proportionally. That's our proportionality theorem. There we are supposed to prove that the sides are in proportion, and it can come as well having many versions that you are supposed to prove, because you can prove that AQ over AC is the same as AP over AB as well. So you must also look at what the question has asked you to prove there on that theorem. Equiangular triangles are similar. You are able to see that you'll be given two triangles that are having different sizes, but you are given information about their angles. You should be able to do your constructions, and you are able to prove whatever the question is requiring you to prove. Now, please, Euclidean geometry, for every statement, there must be a reason. Remember, before you look at the questions, fill in the information in your diagram. Those equal angles, those equal sides, indicate them on your diagram. It will make life easier for you. And as you are doing that, you are able to see which theorem you have applied to get whatever angle that you have marked. And that also helps you to determine the correct reason as you move along. When you now look at questions, your answers are already on the diagram. You are just picking them up and just writing them formally in as your answers. The next part will be trigonometry. Our cast diagram, we must look at our cast diagram and remember the basic definition. Sine is opposite over hypotenuse, SOHCAHTOA. Then you move from SOHCAHTOA, you go to x over r. For your cos, it's x over r. Your sine becomes y over r. And you are able to also find your tan as y over x. Those proofs were done in grade 11 of our identities: cos squared plus sine squared, theta is equal to 1. Tan theta is equal to sine theta over cos theta. We should be able to use those. Now, our reduction rules. We know that we have our cofunctions. In the first quadrant, we are dealing with theta, and we know that all of them are positive because our x and y are positive. We also have 90 minus theta, and we should know that those become cofunctions. If it's sine, it becomes cos. If it's cos, it becomes sine. We move on. Second quadrant, it's 90 plus theta, or we have 180 minus theta. We must be able to recall those reduction rules. Third quadrant, fourth quadrant, I've given you as a way of quickly reminding yourself. Whenever you are dealing with reductions that are above 360 degrees, we subtract or add. If it's a negative angle, you add 360. If it is an angle above 360, you subtract 360 until you get an angle of 360 or less. Then you should be able to apply our reduction rules as I have listed them there. I will move on. In grade 12, we did our compound angle identities. You are able to see them there. We should be able to use them, as well as derive some depending on how the question is structured. our double angle identities for cos double angle and sine double angle are given there. Please use them effectively. Remember, they can work either way. You can be given this side. You are supposed to show that it works backwards and give us that. So trigonometry, we must be able to get all the marks because this has the highest number of formulae and everything else is in the diagram that you are given. Now, we will look at the approach to questions. This will apply to all other topics in paper 2. Read and understand the question scenario. Use the diagram effectively. Analyze the sketch or sketch the diagram depending on the question. You interpret the question, extracting key information, words, etc. You select the correct formula or identity and substitute correctly, performing the correct arithmetic calculations without a calculator to check if it makes sense in most cases. Remember, you must always answer the question and remember to conclude according to what you are supposed to do. And we know that in analytical geometry, Euclidean geometry, and trigonometry, it's often that we have follow-on questions. You must use some information that you have calculated above to help you find something that is called scaffolding. But remember, the opposite is not true. You cannot use 1.2 to answer 1.1 or 6. You use 6.2 to answer 6.1. If a question says sure in 6.2, you cannot use whatever you were supposed to show in 6.2 to answer 6.1. It has to come at the end after doing some calculations. I will just give you a 3-minute break, and in the 3-minute break, you must be looking at that question and trying to find out what you can get from that question. So we will meet after 3 minutes. Let's drink water and stretch and relax and look at that question. Babsho, abakhali. Asathi uphepha wani? Babsho ngithe uyanginikeza lona manje.
Ngiyangikunikeza lona. Mina ngizosala. Ngiyangikunikeza lona. Uzoluthola umsebenzi kusasa.
Baze bengekho esikolweni kusasa. It's in this straight line. Exactly. And this thing is going to see.
Mina ngishaya ngayifundisa. Mina ngikushaya.
Ngifundise kakhulu.
Ngizobeka.
Manje mina yagcina nini?
Sebenza ngokugcina.
I don't think so ngifundise but bekumnandi ngingakalibheki nje.
Got 1 minute 50 seconds.
Wesikhathi sami sijaha kanje.
Uyashaya distinction. Ayashaya.
Compared
Abantu
to
nani
prelim.
Ngihlonipha imensi. Let's complicated. Ngihlonipha like knowing like every topic.
Analysis or photocopy.
Man, it's so complicated. English, yeah. Vele mashaya imethi khona akuna subject engikukhula.
Basihlulo history.
Uyezwe.
History basishaya strong.
Lepe ungayithandi. Uthola sekajovekile sekanzayo nayo.
Taken a break. Now, this question can come. You can be given a diagram drawn, or you can be given that 5 sine theta plus 3 is equal to 0. It can come in that form as well, or they can give you a sketch as you are given. If it comes like that, please check on your diagram. Normally, they will give you theta must be between a certain interval, for example, between 180 and 360 degrees. So you must be able to make sure that you make your sine theta as -3/5, and you are able to see that sine it's negative in quadrant 3 and 4. Then you look at the correct quadrant that you should draw your diagram in. So if they've not given you the interval, it means you can have two diagrams in quadrant 3 and quadrant 4, and you work with them to find out whatever you need to find there. But for this one, it's an easy one. The diagram is already drawn for us. Let's quickly go to the questions. First questions, calculate the value of k. So if you look at this, k is our x and our y is 1. You drop a perpendicular there to form a right angled triangle. Then you use your theorem of Pythagoras. We know that to find the value of k, we are going to have we are going to substitute into the theorem of Pythagoras. X squared plus y squared is equal to r squared. We know that this is theorem of Pythagoras. Then from there we substitute. Our x is k. We have k squared plus 1 squared is equal to square root of 5 squared. From there on, you are able to get your k squared as 5 square root of 5 squared is 5 minus 1, we'll get 4. So we'll get our k as plus or minus 2. But remember, we are working with quadrants. In this case, it's quadrant 2. Therefore, our k must be -2. Please do not just take 2, because we are working with quadrants and the signs are not the same in the different quadrants. So we'll get a mark for using theorem of Pythagoras and then choosing the correct value of k as -2. You will get your 2 marks there. We move on now to 5.1.2. We are supposed to find tan theta. Remember, we know that here we have -2, so the coordinates there are -2 and 1. So from there on, tan theta, we know that tan is equal to y over x, and you are able to see that your y is 1 over negative 2, which means our answer there will be negative 1 over 2. We are done. The next question, we are supposed to find cos 180 plus theta. If you check this is an identity. We should use our reductions because we cannot work with 180 minus theta. The reduction of cos 180 plus theta will give us what? Negative cos theta, because this is in the third quadrant, and we know that in the third quadrant cos is negative. From there on, we know that this will be negative. What is cos theta for this diagram? We know that it will be negative 2 over the square root of 5. And that negative and that negative will give us positive 2 over square root 5. You can rationalize it if you want, but you can leave it like that. We got our solutions as that. So from there on, so this was 2, that one was 1. You are able to get your marks quickly and you move on to the next question. Without using a calculator, we are supposed to solve for C in that form. Remember, like I said, whatever you get scaffolding, you are using it to find the next solution. Remember, we said our k is negative 2, so the coordinates there are negative 2 and 1. So from there on, we are given sine theta plus 60. In this case, this requires us to use compound angle identities, and I know that if I have sine A plus B, this is the same as saying sine A, which is my theta, cos 60 plus cos theta sine 60 degrees. It's a sine cos, cos sine on the expanded form. So from there on, you are using the solutions that you got. For your sine theta, we know that it will be 1 over square root 5. We are substituting. Cos 60 is a special angle, and we know that cos 60 is the same as sine 30 on our special angles plus cos theta. We are able to see that cos theta, you are looking at the diagram, our x is negative 2 over square root 5. Sine 60, we know that it's square root 3 over 2. So the marks goes for our substitution. Then special angles, you must revise them, you must know them. And we should be able to then now simplify and get our solution as 1 minus 2 root 3 over 2 root 5. But we know that 2 root 5 is the same as square root 20. And then we'll get our 5 marks. So we get expansion, substitution of our special angles, simplification. So remember here, special angles as well as that sine theta and cos theta, we are going to get 2 marks for them. Simplification to get there, and then we should be able now to change that to square root 20, and then we'll get our 5th mark there. We move on to the next question. Here is an interesting one. And I know that most of us do not like these kind of questions. Given that cos A minus B is equal to cos A cos B plus sine A sine B, use the formula for cos A minus B to derive the formula for sin A plus B. Use the formula for cos A to derive the formula for sin A plus B. Remember, where do we start? We are given this formula. We need to derive the formula for sin A plus B. What do we know? We know that sine, if I have sine theta, this is the same as saying cos 90 minus theta. So we start from there. Treat this A plus B as your 90 minus theta, as your theta, sorry. And then how will this look like? It would look like cos of 90 minus A plus B. And from there on, I know that I can write this as cos 90 minus A minus B. And I can take that because I want to have cos A minus B. So I can take that as this. Then I'll substitute. Where I'm having cos A, I'll substitute 90 minus A. Where I have B, I will substitute B. And this will give me my cos, when I substitute cos 90 minus A times cos times cos B minus, what will I have? Because it's a plus, sorry, sine 90 minus A times sine B. The reduction of cos 90 minus A, it's a cofunction. Cos 90 minus A, I know that this is sine A cos B plus sine 90 minus A becomes cos A, and that one will give me my sine B, and that will be my final answer using what I was asked to do. Get my 3 marks for substituting my cos 9, for using the cofunction and then simplifying it to get that, and then doing my reductions thereafter. After expansion, then I'll get my solution. Here is another question where we are normally tricked. Given sine 16 degrees is equal to P, determine the following in terms of P. It's bold there without using a calculator. I know most of us, the first thing that you want to do, you want to go to the answer first. Sine 16 degrees calculator. 0, we straight away stop marking. There's nothing to look at. You have not followed instructions. The instructions are without using a calculator, which means we must see a diagram there and we must see some sort of calculations before you get to the answer. It can't just be an answer. So I will give you some time to look at it. 1 minute. Look at it. Then after 1 minute, I will continue with the solution to this problem. Let's have a 1 minute break. Thank you. Welcome back. As you can see, this is almost similar to the one that I illustrated earlier on, where I said you can be given 5 sine theta plus 3 equals 0, and then you are supposed to come up with a diagram. In this case, they've given us sine 16 degrees. The first thing that you must look at, remember, this is our x, that one is our y, and we know that this is 0, this is 90, 180, 270, and 360. In which quadrant does 16 degrees lie? It lies in the first quadrant. Then you come up with a right angled triangle there. We never construct horizontally, we construct vertically for our right angles so that we do not lose marks. So sine, we are able to see that from our identities, sine theta is given by y over r. So it means if we look at sine 16 degrees, this I can write it as a fraction, it's p over 1. So meaning our r is equal to 1. And then we do not have an x value, but our y value is equal to p. So we should be able, because we need to find sine 196. So for that one, we might not need a diagram, but we are able to see that sine 196 is equal to sine 180 degrees plus 16. And this is in the 196. It's in the third quadrant. And we know that in the third quadrant, sine it's negative. So we get negative sine 16 degrees, which means sine 196 will be negative p. So where there is sine 16 degrees, you put its value, which is p, and then we'll get sine 196 degrees is equal to negative p. Then we need to find cos 16 degrees. So for us to find cos 16 degrees, we must find x, because we know that our cos is x over r, or we can use the identity for cos and sine. So let me use the diagram so you are able to see that for us to get x, we are going to use the theorem of Pythagoras. We'll have x squared plus p squared is equal to 1 squared, and meaning x squared is equal to 1 minus p squared. X is equal to plus or minus the square root of 1 minus p squared. Our x, because the 16 degrees is in the first quadrant and our x is positive, we'll take positive square root of 1 minus p squared. Therefore, we'll get our solution as cos 16 degrees will be equal to x, which is square root 1 minus p squared, all this over 1, which will be the same as that. The other alternative that I spoke about, you are able to know that our cos squared theta plus sine squared theta is equal to 1. So then you are going to substitute cos 16 sine 16 squared, and then it will take you back to cos 16 degrees is equal to plus minus the square root of 1 minus sine squared, and then you get your solution there. Please do not have a limited mind. We always have options for our solutions. Do not be afraid. Use them as long as you are able to back them up and you have tried them before. They should work. Our formulas are applying, our identities are applying. We should be able to use them. Now, reductions. Determine the value of 1 over. We are supposed to use our identities to reduce this. So, this will be equal to, let's do the reduction. Cos 360 minus theta, it's in the fourth quadrant. And we know that cos in the fourth quadrant is positive. So we'll have our 1 on the numerator. Cos 360 minus theta becomes cos theta. The reduction of sine 90 minus theta, it's cos theta. We know that minus, that's the reduction of tan 180 plus theta, it's in the third quadrant, and we know that in the third quadrant, remember I can write this as tan 180 plus theta all squared. This is the same as that. So this is the same as writing minus tan squared theta. From there on, I'm able to write this as 1 over cos squared theta minus, I know that tan squared is an identity. It will be sine squared theta over cos squared theta. And this will now give me, if I check, I'm subtracting fractions that have the same denominator. I can write this as denominator cos squared theta 1 minus sine squared theta, and I know that 1 minus sine squared theta is an identity, which gives me cos squared theta over cos squared theta, and this will be equal to 1. Now you will get your 6 marks there. You are able to see how you are getting them. For that, and that, you get a mark. Substituting for tan as an identity, simplifying, and then substituting for the identity 1 minus sine squared theta is cos theta, and then our final answer 1. We will get our 6 marks there. Now, there is another question where we are supposed to calculate the value of sine 2x if given that sine x minus cos x is equal to 3 over 4 without using a calculator. Good people, this is not an equation. It looks like an equation, but you will see when we look at the general solution, it's not a general solution, but it requires us to apply our mathematical knowledge. And for us to be able to answer this one, it means somehow we have to come up with an identity of sine 2x, which will be sine 2x is equal to 2 sine x cos x. From the information that you are given, how do we get 2 sine x cos x from there? Now, our knowledge of solving equation, we are having and expanding sine x minus cos x is equal to 3 over 4. If you multiply by 4 throughout, it will complicate your life. So the easiest thing, let's square both sides and see what happens. So this, you square both sides, you'll get sine squared x minus 2 sine x cos x plus cos squared x is equal to 3 over 4 squared gives us 9 over 16. But what do I realize? That's an identity. So this will give me sine squared plus cos squared. I know this is an identity. It gives me 1. So I'm now having negative 2 sine x cos x plus 1 is equal to 9 over 16. From there on, I know that this is an identity for sine double angle. I will now have, if I take this one that side, I will have sine 2x is equal to 1 minus 9 over 16, and that will give me sine 2x as 7 over 16. Interesting one for 5 marks. You are able to see how we got those marks there, and we should be able to pass. I'll move on now to trigonometric equations. We know how to solve trigonometric equations. If I'm given sine x is equal to negative 0,5, I know that I am able to get my acute angle as my reference angle. I know that sine is negative in quadrant 3 and 4. It means I must have two solutions in quadrant 3 and 4. And I know that in quadrant 3, my solution will be 180 plus my reference angle plus k times 360 degrees, and it will give me the solution. Fourth quadrant, 360 minus, I get my solution. So the methods of solving our trigonometric equations, where k is an element of integers, do not forget that part. 360 degrees is the period, and we will move on to the alternative of solving trigonometric equations. You remember this one? I know we have discussed it before. And for sine, we know that our theta is equal to sine. You shift, get your angle, then plus, and then 180 minus whatever you get as your angle, then we should be able to get our general solution correctly. And remember, for our general solutions, we have different types of trigonometric equations. We have the ones, for example, if I'm given 3 sine x is equal to 4 cos x. Find the general solution. If you move 4 cos x to one side, it will give you 3 sine x minus 4 cos x is equal to 0. You will not be able to go anywhere because you are having sine and cos. So the easiest thing to do is to make sure we know that sine over cos is an identity. Divide both sides by cos x, and that will give us our tan x is equal to 4 over 3. Then from here, you know how to find your general solution for tan using that, and we are able to get our general solution. The second form, it's when you have our equation having sine and cos, but now it's a trinomial. It means you must make sure that you convert that to one type of a trig ratio, either to cos or to sine using identities. Then you solve that trinomial. The third one, it's when we have our co-functions, and normally that comes when we are having our trigonometric functions, where you are supposed to solve 2 sine x is equal to sine, for example, cos x plus 30 degrees. You need to use your co-functions, and one of the angles becomes your reference angle. Then you are able to solve. Sorry, it should be sine 2x is equal to cos x plus 30 degrees. That is the third form of our trigonometric equations. Please, let's practice them. Now, let's look at the general solution. This is the one that I said it's in a trinomial form. We are having 4 sine x plus 2 cos 2x is equal to 2. For us to solve this, we are able to see that our problem is here. We are having sine, cos, and that 2. There's no way we can factorize or use the quadratic formula there, so we should use our identities. So in the interest of time, I will not work it out, but you are able to see that where there's cos, so what happens? You divide throughout by 2 because 2 is a common factor. You remain with that, but you are able to see that this is an identity. So where there is cos x, you put the identity, you end up having your equation in terms of sine only, and you now use factorization and you get your general solution as such. I'll move on to trigonometric graphs. We know our amplitude, it's the stretch of our graph, and for us to get the amplitude, please, amplitude does not have a sign. It is the displacement from rest to maximum or minimum point on our graph, and we are able to get amplitude using that. You take your y values at the maximum and minimum, you subtract, and you get your amplitude. It does not have a sign. Our vertical shifts, we know that it's the cos ax plus q. It shifts our graph up and down. Our period shifts, it's when we have cos 2x, cos half x, sine 2x, and then that will affect the period shift, and we are able to see that when our period shifts, you are able to use the period of a sine graph is 360 degrees. You divide by whatever is the coefficient. If it's cos 2x, it means the period for this graph will be 360 degrees divided by 2, which means the period will be 180 degrees. Also, what can help us? On the same set of axes, try to draw the basic graph. For example, you draw this graph of sine x, the graph of cos x, the graph of tan x. Then you are able to see what is different in terms of the x-intercepts as well as the maximum and minimum turning points there. It will help you to determine your period faster as well. We must know how to sketch graphs without using a calculator, because that is what is killing our trigonometry. People no longer want to use the basic understanding of our original graphs, so that you are able to see these shifts by looking at the two graphs. Rather, we want to punch information into the calculator that we fail to interpret later on. But we must try by all means to know the basic way of sketching our graphs, and we must know the properties of the original graphs, sine, cos, and tan, in terms of their maximum turning point, minimum turning point, their x-intercepts, and so on. Now, Shifting the graph x plus 30, just like in functions in paper 1, if there is a plus, it means it shifts so many degrees to the left. If it's a minus, it shifts so many degrees to the right. We should be able to interpret and use that. Here is a question. We are given the graph of negative cos 2x between negative 180 degrees and 180 degrees. Draw the graph of f of x is equal to 2 sine x minus 1 in the given interval on the axis provided. We are going to sketch that, draw that graph on the same set of axes. Now, let's use the properties. You are able to see that our amplitude must change because of that 2. We know that our graph must shift also 1 unit down. So if you compare the graph of sine x and the graph of sine 2x, we know that the graph of sine x will have a maximum at where? That is coming to you. You have forgotten this. Please make sure you go back. But we are able to see that it will have a maximum at 90 degrees if it is the graph of sine x only. But because of this, our amplitude, you are able to see that it's 2 and we are shifting it 1 unit down. That is why our maximum here will be 90 and 1. Our minimum here will be negative 90 degrees and negative 3. Remember, the graph was supposed to look the graph of sine x, of 2 sine x, then it comes down like that. So it shifts 1 unit down because it was supposed to be negative 90 degrees and 2 without this shift of negative 1. So we should be able to draw our graph and get the information. So for sketching this, the correct 180 and negative 1, you have your shape, you have your x-intercept, maximum, minimum, turning point, and the correct shape, you'll get your 3 marks for the graph. We move on now to the next question. It says, write down the values of x for which g is strictly decreasing. If we are looking at this graph, remember it increases up to a maximum turning point, then it starts to decrease up to a minimum, then starts to increase again, and then it starts to decrease again. Check the interval where you are finding the solution. It's between negative 180 and 0. So where is the graph decreasing? It's decreasing from here up to the minimum turning point there. But you are taking the x values as your answer. So it will be from negative 90 degrees to 0 degrees. We move on to the next question. Now, as we write our solution, remember we should get the correct values as well as our endpoints, as well as our inequality signs, or our interval notation must also be correct for us to get all the marks. Write down the values of x for which f of x plus 30 degrees minus g of x plus 30 degrees is equal to 0. Now, if you look at this, this is talking about the shifts. So minus 0, all you need to do there is to interpret the question correctly. You are saying you want to find the region where f of x plus 30 degrees is equal to g of x plus 30 degrees. you are going to use the original graph. If you check, F and G are intersecting at 90 degrees, that point. They are also intersecting at 180 degrees. They are also intersecting here at 0, as well as here at negative 180 degrees. But now, remember, you are shifting this 30 degrees to the left. So 90, so it means both graphs are shifting 30 degrees to the left. So it means 30 degrees to the left, 90 minus 30 will give us how many degrees? It means it will be somewhere here at 60 degrees. 180 minus 30 degrees, it means it will be somewhere here, which is 150 degrees. 0 minus 30 degrees, it means it will be somewhere here at negative 30 degrees. Negative 180 minus 30 degrees, it will give us negative 210. But because of the interval restriction, our solution must be on the given interval, as you are able to see what we are expected to get there. So that will be our solution. 1 and the other 2 are also 1 mark. So we should be able to get that by interpreting the graph, not by doing calculations. Now we move on to trigonometry in 2-dimensional or 3-dimensional problems. The tips are, please fill in the missing information in your diagram. You must identify and redraw a triangle where the wanted is and where the most factors are found. The triangle with the most information, you use it to find what you can get is next. And we must identify the common side. Folding will help you. And do not forget about the basic trigonometric ratios. In a right angle triangle, we know that sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. We should use that. Now, the rules. We know our sine rule, we know our cosine rule, we also know the area rule. Please revise them and see where they apply. I've given a hint there. For you to use a sine rule, you must have 2 sides and a non-included angle, or you must have more than 1 angle or more than 1 side. Are you able to see that? And then the cosine rule is used when you are given 2 sides and an included angle, or when you are given 3 sides. You can use your cosine rule. For area rule, you must be given 2 sides and an included angle, and we should be able to do this example to help us see what can help us answer 2D and 3D trigonometry. Please try by all means to redraw a triangle that can help you get the solution. We are told that from point A, an observer spots 2 boats, B and C, at anchor. The angle of depression of a boat B from A is theta. D is a point directly below A and is on the same horizontal plane as B. Now, it says BD is 64 meters, AB is 81 meters, and AC is 87 meters. The question is, calculate the size of theta to the nearest degree. Redraw the triangle. I will draw triangle ABD. my right angle. My A is up there, my D is here, and my B is here. Now, this is a right-angled triangle. What else do I know? They are saying the point D is directly below point A and is on the same horizontal plane with that. So BD is a straight line, and I know that for me to measure an angle of depression, I know that this must be parallel to A for me to get that one as theta. And I know that from that line of measuring the angle of depression, I'm able to see that I'm having parallel lines, because that point is a horizontal line. BD is also a horizontal line. It means if I call this one Z, I know that ZA is parallel to BD. Therefore, I have alternate angles. This will be theta. This side BD is 64 and that side is 81. So from there, I'm now able to use my trigonometric ratios. So for me to get theta, I have an adjacent side and a hypotenuse. So the easiest trigonometric ratio to use will be cos. So from there, I'm able to say my cos theta, because this angle is equal to that, cos theta is equal to my adjacent, which is BD, over the hypotenuse, which is AB. Then I substitute cos theta is equal to 64 over 81. Using your calculator, you get your theta angle there. Now, redrawing the triangle helps you to see. Do not draw it slanting the way it is drawn, because that is where we miss some of the information. Draw it in two-dimensional so that you are able to see what can help you answer there. We'll move on. So angle of elevation is equal to angle of depression. That is why I said you can use ZA parallel to BD. It depends on how you want to put it. Then you get your theta as 38 degrees to the nearest angle. We move on now to the next question. It says, if it is given that BAC is equal to 82,6 degrees, calculate BC, the distance between the two boats. Now, when you are looking at that diagram, it looks complicated, but redraw the triangle BAC and add information to it. You'll be able to see that this angle here, we are given BAC. It is given as 82,6 degrees. That's A, B, C. You are redrawing the triangle. The length of AB we have, it's 81. The length of AC is 87. We want to find BC. We are given two sides and an included angle. It means cosine rule is going to help us. So rewrite the cosine rule. BC squared is equal to AB squared plus AC squared minus 2AB times AC cos of A, which is 82,6 degrees. You substitute that into the formula, you'll get the distance BC as 110,97 meters. We get our 3 marks there. So cosine rule, substitution, answer. But redrawing the triangle helps you visualize what you have, and add information into the diagram will help us a lot. Right, we move on to the next question. It says, if BDC is equal to 110 degrees, calculate the size of DCB. Again, redraw the triangle. These are in the same plane, so the triangle would look something like that. This is our B, our D, that's our B, and that's our C. Remember, BDC, this angle is 110 degrees. BD is 64. BC, we have calculated it. And we found its length as 110.97. 110.97. Now, we want to find this angle here. What can help us? I have an angle and a side, and that side is opposite that angle. Sine rule becomes easier for me to use, and I'll use sine rule to find the size of that angle BCD. I hope you are able to see that redrawing the diagram helps you a lot to see what can help you get to the solution faster. Now, let's move on. Common errors for trigonometry. We write amplitude as a negative. We confuse amplitude with period. Please revise them in the next 2 days. Making assumptions. This applies in all the topics through the entire examinations. Please do not make assumptions. Incorrect simplification. Analytical geometry, I know. If they have not said a point is a midpoint, you can't use the midpoint formula. If they have not marked the sides as equal or the angles as equal, there is no bisection, so we can't use the midpoint formula there. Let's know our notations in our mathematics. Incorrect signs when doing reductions. You saw when I was doing reductions, put in brackets and the reduction goes with its sign so that you do not lose track of your signs. For 2D and 3D problems, I've indicated, try to redraw the triangle. Work with one triangle at a time. Do not work with a block diagram. Do not use a calculator if the question states clearly that a calculator should not be used. So, in summary, always analyze the given information. Always remember that diagrams are not drawn to scale. Do not start measuring angles and sides using a ruler or a protractor. We must use given diagrams effectively. Also, if you are drawing a diagram, make sure that it makes sense to you as well. Label correctly, and you must know the different notations that are used in the subject. Gradient, we use gradient of AB. That's the notation we use in maths. If it is the midpoint, we use capital letters and we have brackets like that. If our angle is theta, theta equals. In Euclidean geometry, calculate the size of angle B1. B1 equals. Do not just write things because we end up losing marks because we don't know now what you are answering, because sometimes some of us, when we are answering in the answer book, you realize you have answered a certain question, you forget to change the numbering. But if your information is showing the correct thing, it will assist because it shows you know what you are doing. Write all the given information in the diagram in the answer book so that even if you do not get time to answer in the answering space, at least the solution is seen somewhere in your work. Rough work must be done on the answer book, not on the question paper. Now, I'll emphasize on this one. You cannot use a follow-up question to answer a previous question. I have said this before. revise properties of triangles and quadrilaterals thoroughly as they come, both in Euclidean geometry as well as analytical geometry, as well as trigonometry you have seen again. Use of color is encouraged for you to visualize what is happening. We must refrain from making assumptions. This is coming back again. Good luck for your paper 2 examination and all the best. Please do not entertain anything that has to do with paper 1. Otherwise, it will be meant to make sure that you become disorganized and disoriented. I know there are people who will be starting to send things around. Please do not even open them. Concentrate on the revision of your paper 2. And I wish you all the best. Thank you so much for working with us for the whole year. Continue to watch our videos as you practice for paper 2. I wish you all the best. Thank you. Have a good afternoon.